For thousands of years, humanity has gazed up at the moon, a silent silvery companion in our night sky. It's inspired poetry, guided travelers, and sparked countless dreams of exploration. Over 50 years ago, we took that giant leap for mankind, walking on its dusty surface. You'd think that after all this time, we'd have it all figured out, right? Well, think again. The moon is still one of the most mysterious places in our celestial neighborhood, holding secrets that could completely change the future of humanity. One of the biggest mysteries, and perhaps the most exciting, is something we once thought impossible: water. Yes, you heard that right. The dry, desolate world we thought we knew might be hiding vast reserves of water ice. For decades, the scientific consensus was that the moon was bone dry. Any water it might have had would have been blasted away by the solar wind or vaporized by the sun's harsh radiation billions of years ago. But recent discoveries have turned that idea on its head. It all started with tantalizing hints. Data from missions like NASA's Lunar Prospector in the 1990s detected high concentrations of hydrogen at the lunar poles. Where there's hydrogen, there could be water, locked away as H. Then, in 2009, a mission called LCROSS did something dramatic. It deliberately crashed a probe into a crater near the moon's south pole. The resulting plume of debris was analyzed, and the results were stunning. Definitive proof of water ice. It was a game changer. Suddenly, the moon wasn't just a rock, it was a potential oasis in the vast desert of space. But here's where the mystery deepens. This water isn't just sitting in a big, convenient frozen lake. It's hiding in the most dangerous, hard-to-reach places on the entire lunar surface, the permanently shadowed craters at the poles. These are some of the coldest spots in the entire solar system, with temperatures dropping to hundreds of degrees below zero. Sunlight has not touched the floors of these craters for billions of years. They are eternal pits of darkness and extreme cold, perfect natural freezers for preserving water ice. So, why is this water so important? Well, for starters, it's the key to making humanity a multiplanetary species. Think about it. Launching anything from Earth is incredibly expensive. A single bottle of water can cost thousands of dollars to get into orbit. If we could access water directly on the moon, we wouldn't have to carry it with us. We could use it for drinking, for growing food in lunar greenhouses, and even for creating breathable air by splitting the water molecules into hydrogen and oxygen. But the real holy grail is rocket fuel. Both hydrogen and oxygen are powerful rocket propellants. If we can mine lunar ice and turn it into fuel, the moon could become a cosmic gas station. We could launch missions from the moon to Mars and beyond for a fraction of the cost, using its lower gravity to our advantage. It would open up the entire solar system for exploration and settlement. The moon would no longer be the destination. It would be the starting line. This potential has kicked off a new space race, one that's less about planting flags and more about setting up shop. Two major players are leading the charge: China and the United States. China's Change program has been making incredible strides. They've landed on the far side of the moon, a feat never before accomplished, and have brought back lunar samples for the first time in decades. Their roadmap is clear. They are planning to establish an international lunar research station near the South Pole in the 2030s. A permanent base for robotic and, eventually, human operations. They're systematically scouting the best locations, analyzing the terrain, and trying to pinpoint exactly where the largest and most accessible water ice deposits are. On the other side, you have NASA's Artemis program. Its goal is ambitious and inspiring: to land the first woman and the next man on the moon, specifically near the South Pole, by the middle of this decade. Artemis isn't just about a return visit, it's about building a sustainable presence. They plan to construct an Artemis base camp, a lunar outpost where astronauts can live and work for extended periods. A crucial part of this plan is a robotic rover called Viper, which stands for Volatiles Investigating Polar Exploration Rover. VIPER is designed to be a water hunter. It will drive into those dark, frozen craters, drill into the lunar soil, or regolith, and map out the concentration and distribution of water ice. This mission is critical. It will tell us if the water is in thick, pure sheets, or if it's mixed in with the soil like frost in a freezer. The answer will determine how we build our mining equipment and whether lunar colonization is truly feasible. But getting to this water is a monumental challenge. These permanently shadowed craters are not friendly places. First, there's the darkness. Solar-powered rovers are useless here. Any machine or astronaut venturing in will need powerful batteries or some other energy source, like a small nuclear reactor, to survive and operate. Then there's the terrain. We have very little high-resolution imagery of what the floors of these craters actually look like. They could be smooth and flat, or they could be treacherous fields of boulders and steep slopes. Navigating in near-total darkness through an unknown, hazardous landscape is an engineer's nightmare, and the cold is an enemy unlike any other. At temperatures of -240 degrees Celsius or -400 degrees Fahrenheit, normal materials become brittle and can shatter like glass. Lubricants freeze solid. Electronics fail. Designing equipment that can withstand this extreme environment for long periods is one of the greatest technical hurdles facing these new lunar missions. It is a race to invent new technologies and materials that can handle the most hostile environment we've ever tried to explore. Furthermore, scientists are still debating where this water came from. Was it delivered by comets and asteroids that crashed into the moon over billions of years? Or could it have been created by the solar wind, where hydrogen ions slam into oxygen-bearing minerals on the lunar surface, forming water molecules over eons? Or maybe it's even bubbling up from the moon's interior, a remnant of ancient volcanic activity. Understanding the water's origin is crucial, because it tells us how much there might be, and whether it's a finite resource or one that is slowly being replenished. If it's from comets, it's a limited treasure. If it's being continuously created by the solar wind, it could be a sustainable resource for generations to come. So, here we are, on the cusp of a new era of exploration. The next decade will be one of the most exciting in the history of space. We will see nations and private companies alike race to the lunar South Pole, venturing into the darkness to unlock the secrets of lunar water. The challenges are immense, the dangers are real, but the rewards are world-changing. The answers we find in those cold, dark craters won't just tell us about the history of the moon. They will write the future of humanity among the stars. The silent, silvery orb in our sky is about to get a whole lot busier and a whole lot more interesting. It's a mystery story playing out on a cosmic scale, and we all have a front row seat. Thank you so much for watching. What do you think is the biggest challenge in mining water on the moon? Let me know in the comments below. And if you enjoyed this journey into the mysteries of space, don't forget to hit that like button and subscribe for more adventures. We'll see you in the next one.